Okay, I'm actually showing my project, which I have done at DDes. So um, the project called Performance-Based Hybrid Shoreline. This is my doctorate project focusing on computational design, sustainability, material science, and digital fabrication. The project has been collaboration between the CREST, which is an NSF supported center at FIU. My focus is on coastal areas. Our coastal area are under significant distress due to climate change and sea level rise. And extensive corrosion and frequent flooding and depopulation of marine species are only a few of these issues. Most of these problems triggers by severe events such as tropical storm, hurricane, and high tide. To protect coastal line, one of the common and widely used technique is creating a hard infrastructure, which means creating a concrete barrier along the shoreline to protect it from the wave attack. This strategy is causing more harm to our ecosystem by making the coastal area more vulnerable to storm, high tide, and coastal and destroying the coastal habitat. The methodology I'm using it here, it's hybrid infrastructure, which means it's a nature-based solution that integrate nature with gray infrastructure such as riprap and natural elements such as salt marsh, mangrove, and to create a more resilient shoreline. The aim here is not only to protect coastal area from erosion, but also collect sedimentation and filter water, as well as promote biodiversity using natural elements such as mangrove and seagrass. To put this concept and design framework to test, I have selected FIU BBC campus as a project site. The project began with site analysis and the data that it's needed, it's been provided through USGIS, ArcGIS to incorporate into multi-layer map. To create this overall topography, I have used a sine wave equation, which the data was gathered from National Weather Services. And variation of these landscape, it's been created using this algorithm. To occupy the selected topography, I have used this algorithmic definition, which is inspired by rock formation, that it's natural phenomena happens along the shoreline, and it's a volcanic eruption creating this Voronoi pattern, which create this Voronoi pattern modular that gives opportunity to create and self-organize and adapt to the site. Here's the integration of the tile and topography. In this image, illustrate how the nature is integrated with this biotile. And these biotile perform as a nursery for mangrove and seagrass, and also filter stormwater using these retention ponds. Finally, using this methodology, 4 different typology, it's been created, and each one has its own functionality. Starting with biomarine solid tile, data optimization. To optimize these tile, I have used solar data radiation as an input. I increase to increase the thermal comfort for marine habitat in the intertidal zone area by varying the height and maximizing the self-shading on the surface area. And also use this color-coded map for storm surge category 4 to determine the high-risk zones and adjust the biotile height accordingly. Next, I'll be talking about the marine holotile, which actually collects sedimentation. The data optimization for this tile, I use the optimization algorithm and using the data collected, water data collected from the site. And the greater the turbidity level of the water, the steeper the slope of these tiles become to collect more sedimentation. And eventually a reduced turbidity level, which means less particle, cleaner water. Here I'm gonna be talking about the material research that I have done. I have conducted research into developing more sustainable concrete mix design. To minimize the minimum ratio, cement ratio, I have replaced volcanic ash and lime powder to reduce the ratio. And also I have looked into olivine, which is a natural mineral that captures CO2 and from the water and also lower the acidity. And I have conducted various laboratory tests like compression strain test as well as leaching tests, and selected material that was fulfilling most of the criteria was Roman olivine. The next goal that we had was having increased biodiversity. To increase biodiversity, I look into various literature study, and I realized that by creating texture on the surface, the marine species can attach to them. And by doing so, they protect as a barrier against weathering and erosion and make the concrete more durable and reduce the maintenance and upkeeping. This process called bioprotection, basically. Here are the biomarine tile category and the macro habitat associated with each typology. The fabrication of these tiles actually to make ununiform Voronoi tile, it's challenging. The goal was to create and develop a formwork that is adaptable and the tile can generate it at the site. In order to test the performance of biotile, I have been working and creating these typology using innovative manufacturing technology. These sample tiles also with different texture has been fabricated and placed along the shoreline to be monitored and see their reaction and effects for accumulation of marine biodiversity. And only by a few months, we can see some macroorganism living on them. Next would be biopod tile, which is a hollow texture ceramic tile with a hole in the center that can house mangrove seeds. To restore a mangrove tree, it's quite a challenging task. I have studied and see a new novel technique that suggested to maintain juvenile mangrove tree at the nursery prior into transplanting it at the site. The biopod tile are actually made from unglazed ceramic material, which is a non-toxic to our environment. And ceramic pots typically increase air movement to the and helps promote the root growth. And to analyze the structural integrity of the proposed infill and structure support, I use finite element ANSYS. The fabrication technology here is additive manufacturing with using ceramic extrusion. The requirement for parameters are to create this texture, to create this pod. It's actually robotic speed, degree of extrusion, and structural support. Next, it's bio-seagrass tile, which is an interlocking planter that allows seagrass to grow and stabilize on the seabed. Data optimization of seagrass. The objective is just to cover solution through examination of innovative case study and also to understand how the seagrass restoration it's been happening in the current severe condition. I used the data collected from through interview question from marine scientists. The comments by interview actually been converted into the pseudocode and visual diagrams. And the code also divided in 3 major themes. This process is iterative and the design intervention evolves after each interview. After this various interviews and iteration, finally a set of star-shaped interlocking with a slight variation in the geometry was created in order to evaluate various interlocking. The construction process, it's relatively straightforward, and creating these cushion-like structure, I use a ball rock fabric and with the mix of infill. In this short video, I'm trying to show how the integration of nature-based solution with this multi-purpose artificial infrastructure create an aesthetical pleasing landscape and provide people with a unique experience with their local environment. And these are the seagrass pods. Oops. I think my screen jumped out. And finally, this is the showing how these performance biotalids being placed and monitored along the shoreline to evaluate their performance and their impact on the shoreline. And if these trials are successful, this methodology can expand and apply in different ecosystem in needs and of protection and restoration. And here's my website. I usually post the update of the project and my contact information. Thank you for watching again.